Hello everyone, it is a audio recorded lecture on the topic S block elements. In this chapter, we will study introduction of group 1 and group 2, general characteristics, physical properties, chemical reactivity, and reducing nature. Introduction. First, elements of group 1 and group 2 of the periodic table are called S block elements. Second, for these, outer s orbital is in the process of filling. C. Group 1 configuration is Ns1 called alkali metals and group 2 with Ns2 configuration calls alkaline earth metals. General characteristics. They are good conductor of heat and electricity. They are malleable and ductile. Exhibit group valency of 1 and 2 for group 1 and group 2 respectively. They are prepared by the electrolysis of their fused salts. They are very reactive as their last shell contain 1 or 2 electron which can be given off easily. They form colorless compound except chromates, dichromates. Their cations are dimagnetic. They form ionic compounds except lithium and beryllium. Their solution in liquid ammonia are good conductor of electricity and are good reductant. Oxides are basic in nature. Group 1 Alkali metals. The elements in group 1 are lithium, sodium, potassium, rubidium, cesium, and francium. Physical properties of group 1. First, physical state. They are soft, silvery, white metal having a high and bright luster when freshly cut. They all form body-centered lattice. Softness increases with increase of atomic number because there is a continuous decrease of metallic strength on account of an increase in atomic size. Second, atomic size. These elements are largest in size in the period and the atomic size increases on going downwards the group. Order of size. Beryllium is the smaller, then lithium, then magnesium, then sodium, then calcium, then strontium, then barium, then potassium, then rubidium, then cesium. Third, oxidation state. These metals exhibit +1 oxidation state. Difference of their second and third ionization potential is more than 16 electron volt. Therefore, their +1 oxidation state is more stable. Fourth, density. Density is equal to mass upon volume. Atomic weight increases from lithium to cesium in the group and volume also increases. But increase in atomic weight is more as compared to volume. Therefore, density increases from lithium to cesium. Exception, density of sodium is more than density of potassium. Fifth, tendency of formation of ionic bond. One electron is present in the outermost shell of these metals. They form cation by the loss of this electron, that is, they form ionic bond in their compounds. Sixth, standard electrode potential or standard oxidation potential. The measure of the tendency of donating electron of a metal in water is called its electrode potential. If concentration of metal ions is unity, then it is called standard electrode potential. Seventh, colorless and dimagnetic ions. The property of an ion as being colorless or colored depends on the number of unpaired electrons present in the ion. If unpaired electrons are more in an ion, then these electrons get excited by the atmospheric energy and show color on coming back to the ground. Intensity of the color is directly proportional to the number of unpaired electrons. The ions which have unpaired electrons show magnetic properties, whereas the ions having paired electron nullify the magnetic field of each other. Such ions are called dimagnetic ions. Eighth is flame test. Alkali metals have large size. When they are heated in the flame of Bunsen burner, the electrons present in the valence shell move from lower energy level to higher energy level by absorption of heat from the flame. When they come back to the ground state, they emit the extra energy in the form of visible light to provide color to the flame. Elements and their respective color imparted to the flame are given below. Size of cesium is large and one electron is present in its outermost shell. Due to this, electron of outermost shell get excited by absorption of visible light. Therefore, cesium show photoelectric effect. This is the reason it is used in the cells. 10th is solubility in liquid ammonia. Ionization potential is low due to large size of these metals. That is, they readily dissolve in liquefied ammonia to form blue colored solution, which is a good conductor of electricity and a strong reducing agent. 11th is hydration enthalpy. Hydration energy decreases on going down the group due to increase in size of metal ion. Lithium gets more hydrated due to high hydration energy of lithium ion and the charge present on it get protected. Thus, hydration energy is inversely proportional to ionic size. 12th, reactivity. Due to large size of these metals, the electron of the outermost shell is weakly attracted towards the nucleus. So sodium is very reactive and it is kept in kerosene so that air does not come directly in contact with sodium. Lithium is stable in air due to small size. Sodium and potassium become neutral and rubidium and cesium burn spontaneously in air. Lithium hardly react with steam, whereas cesium react even with cold water. Lithium forms only one of oxide because ionization potential of lithium is high. Superoxide are paramagnetic and colored due to presence of unpaired electron. Order of their stability is as follows: normal oxide, then peroxide, then superoxide. Next, lustrous surface. Luster is due to mobile electrons in the metallic lattice. Valence electron generated vibration in the electric field of the light waves. The vibrating electrons emit electromagnetic energy in the form of light, and thus the surface of these metals start shining. Next, tendency of forming complex compounds. A complex compound is a compound which give a complex ion on ionization. For example, K4FeCN6 gives K plus 1 and a complex ion FeCN6 minus 4 on ionization. Complex compounds are formed by metal which has very small size of cation, maximum charge on the cation, vacant d orbital in the cation. Next, strength of metallic bond. Metallic bond is weak due to presence of one electron in the valence shell and the BCC structure. The packing efficiency is 68%. Thus, packing of atoms is loose and these elements are soft. These metals are soft because one electron is present in their valence shell, which participate in bond formation. Thus, metallic bond is weak. Atomic size increases in the group from lithium to cesium, due to which strength of metallic bond decreases. This is the reason why lithium is hard, but sodium and potassium are soft, whereas rubidium and cesium are liquid due to weak metallic bonds. Sheets and wires can be prepared from lithium because of its hardness. Melting point and boiling point. Their melting and boiling point are low due to weak metallic bonds. Strength of metallic bond decreases in the group from lithium to cesium, due to which hardness from lithium to cesium increases. Thus, melting point and boiling point are directly proportional to strength of metallic bond. Next is reducing power. The reducing power of a metal is related to its oxidation potential, which represents the tendency of an element to lose electron and get oxidized. All alkali metals have low ionization enthalpy, leading to a high oxidation potential. Next is chemical properties. First, reaction with oxygen. Alkali metal ignites in oxygen and form oxides. Lithium forms stable oxide, Na form peroxide, and rest of the metal form superoxide. Oxide of alkali metals are basic in nature and basic character increases from lithium to cesium as ionic character increases. Peroxide and superoxide behaves as a strong oxidizing agent. Superoxides on treatment with the dilute acid form peroxide, oxygen and hydroxide. Second reaction with water. Hydrogen is liberated. Basicity of hydroxide increases down the group due to increase in electropositive character. Third reaction with hydrogen. Alkali metal hydrides are formed when metals are heated with hydrogen. Metal hydrides are ionic, they are good reducing agents. Reducing power increases down the group. Fourth, reactivity with halogen. Halides are ionic compounds having negative enthalpy of formation. The most negative enthalpy of formation occurs with fluorides. The negative value decreases as fluoride, chloride, bromide, iodide. Lithium fluoride is insoluble in water due to very high lattice energy. Cesium iodide is insoluble in water due to very low hydration enthalpy. Rest of the halides are soluble in H2O. Metal hydroxide. Basic strength of metal hydroxide increases with increasing electropositivity of metal. Solubility of hydroxide increases with increased ionic character. Sixth, reaction with dilute acids. Due to alkaline nature, these metal react rapidly with dilute acid and the rate of reaction increases from lithium to cesium because of increase in basic character. Next is metal carbonates. All these metal forms M2CO3 type carbonates. Basic character, ionic character, melting point, boiling point. These carbonate increases from carbonates of lithium to cesium. Stability of carbonate of group 1 metals is more than stability of carbonates of group 2 metals. Nitrides. Among all alkali metal, only lithium directly combine with the nitrogen to form nitride. Other alkali metal combine indirectly with nitrogen because lithium nitrate is covalent, and as the metallic character increases, the tendency of donating electron and forming ionic bond increases, due to which strength of metal nitrogen bond decreases. Sulfates, basic character, ionic character, melting point, boiling point, solubility, thermal stability, and reactivity increases from lithium to cesium. Nitrates, their basic character, ionic character, solubility, melting point, and thermal stability increases from lithium to cesium. Lithium nitrate decomposes to lithium oxide at low temperature, whereas sodium nitrate get decomposes to sodium nitrate. Next is hydrides. Lithium react with hydrogen due to its low electropositive character. Lithium is less electropositive and thermal stability on lithium hydroxide is high. They are ionic hydrides and their stability depends on lattice energy. Next is anomalous behavior of lithium. Lithium is hard due to which its melting and boiling point are higher as compared to other metals. Lithium hydroxide is weak base as compared to other hydroxide. Lithium forms single type of oxide, whereas sodium, potassium, rubidium and cesium form many type of oxide. Lithium chloride is insoluble in water, whereas other chlorides are soluble. Lithium chloride get dissolved in benzene, petrol and ether. Due to small size of lithium ion, its hydration energy is high. Lithium does not get affected easily by moist air, therefore, it can be kept open in the air, whereas other metal form oxide. Due to high hydration energy of lithium, its conductivity is low. Lithium directly combine with the nitrogen to form lithium nitride, whereas other metal do not form nitrides. Phosphate, oxalate, chloride, bromide, sulfate, and carbonate of lithium are insoluble in water, whereas the above compounds of other alkali metals are soluble. Due to small size of lithium, its ionization potential, electronegativity, and electron affinity are higher than those of other alkali metals. Due to covalent character of lithium chloride, their melting point and boiling point are lower than those of alkali metal halide. Diagonal relationship similarities with magnesium. Lithium shows resemblance with magnesium, an element of group 2. This resemblance is termed as diagonal relationship. Electronegativity of lithium and magnesium are quite comparable. Atomic radii and ionic radii of lithium and magnesium are not very much different. Atomic volume of lithium and magnesium are similar. Both have high polarizing power. Nitrates of lithium like magnesium decompose to give oxide, whereas all other alkali metal nitrates give nitrite. This is all about group 1. Now group 2, alkaline earth metal. Group 2 contain beryllium, magnesium, calcium, strontium, barium and radium. Physical property. First, ionic size. Size of these elements are small as compared to alkali metal and it increases on going down the group. Oxidation state. Metal exhibit plus 2 oxidation state. Density. Atomic weight increases from beryllium to barium in a group and volume also increases. But increase in atomic weight is more as compared to volume, therefore density increases from beryllium to barium. Exception. Density of magnesium is more as compared to calcium. Fourth, tendency of forming ionic bond. There are two electrons in the outermost shell of these metals which are donated to form ionic compound. Fifth, standard electrode potential or standard oxidation potential. Size of these metals is smaller than that of alkali metals. Therefore, their ionization potential will be higher than those of alkali metals. That is, they have low tendency of donating electrons as compared to alkali metals. Sixth, colorless and dimagnetic ions. These metals form dipositive ions. These dipositive ions have noble gas configuration and their compounds are colorless because all the electrons are paired. Their ions are dimagnetic due to the presence of paired electrons. Seventh, flame test. Size of beryllium and magnesium is very small and their electrons are strongly bonded to the nucleus. These electrons cannot be excited to higher energy level by the flame of burner. Thus beryllium and magnesium do not impart any color to the flame. Elements can form Elements and their respective color imparted to the flame are given below. Calcium has brick red color, strontium had blood red color, and barium has apple green color. Eighth is photoelectric effect. Due to small size of these metal as compared to alkali metal, their ionization potential is high. Thus, electrons can be released only by high energy radiation. Ninth, solubility in liquefied ammonia. Due to small size of beryllium and magnesium, their ionization potential is high. Therefore, they do not dissolve in liquid ammonia. Calcium, strontium, and barium give ammoniated electron by getting dissolved in liquid ammonia due to large size, due to which the solution turns blue. Tenth is hydration energy. Hydration energy of the metal ion is higher than that of the elements of group 1 because the size of this cation is small and charge is high. Hydration energy decreases on going down the group due to increase in size of cation. 11th, reactivity. Due to small size of these metal as compared to alkali metal, the alkaline earth metal are less reactive than alkali metals. This reactivity increases from beryllium to barium with increase in the size of metal. Beryllium does not react with hot water, magnesium react with hot water, whereas calcium, strontium and barium react even with cold water. All these metals react with oxygen to form MO type oxide, but due to low ionization potential and high reactivity, calcium, strontium and barium form peroxide also at low temperature. Beryllium and magnesium are less reactive due to their high ionization potential and they form normal oxide because of breaking of oxygen-oxygen double bond. 12th, lustrous surface. Luster is good to mobile electron in the metallic lattice. Valence electron generated vibration in the electric field of the light waves. The vibrating electrons emit electromagnetic energy in the form of light and thus the surface of these metals starts shining. 13. Tendency of forming complex compounds. These metals have weak tendency of forming complex compound due to large size, low charge density and absence of vacant orbital. But these metals have higher tendency of forming complex compound as compared to alkali metals due to their relatively smaller size. This tendency decreases from beryllium to barium. 14th, strength of metallic bonds. There are two electrons in the outermost shell of those metals which participate in bond formation. Therefore, metallic bond is weak but a little bit stronger than the element of group 1. Their atomic size is smaller as compared to element of group 1. Therefore, these metal form strong metallic bond as compared to metal of group 1. 15th, melting and boiling point. Melting and boiling point of these metals are low, but these metals are harder as compared to metals of group 1. Thus, their melting and boiling point are higher as compared to metal of group 1. Next is reducing nature. The alkaline earth metal have the tendency to lose electron and change into bivalent cation. Hence, they act as a strong reducing agent. The reducing nature increases as the atomic number increases. Next is chemical properties. First, reaction with oxygen. Except beryllium and radium, all other metals, when burnt in oxygen, form oxide of type MO. Beryllium oxide is amphoteric in nature, while all other oxides are basic in nature. Basic nature of oxide increases from beryllium to barium. Second, action of water. Magnesium decomposes boiling water. Beryllium is not attacked by water at any temperature. Calcium, strontium, barium and radium decomposes cold water and evolution of hydrogen gas. Beryllium hydroxide is amphoteric but other hydrides are basic. The basic strength increases from beryllium to barium. Solubility of hydroxide also increases from beryllium hydroxide to barium hydroxide. Third is hydride formation. Except beryllium, all other metal directly combine with hydrogen to form hydrides of type MH2. Beryllium hydroxide and magnesium hydroxide are covalent hydride, while other hydrides are ionic in nature. Ionic hydrides are violently decomposed by water evolving hydrogen. Fourth, halides. Metal directly combine with halogen to form halide. Beryllium halide is covalent in nature, whereas other metal halides are ionic solids. These halides are hygroscopic in nature and readily form hydrates. Fifth, carbonates and bicarbonates. Carbonate of metal are insoluble in water. They dissolve in presence of CO2 only. Solubility of carbonate decreases on moving down the group while stability increases. Next, sulfate. Solubility of sulfate decreases on moving down the group. Solubility depends upon hydration energy of cation, which is maximum in beryllium ion. Next is complex formation. Beryllium ion and magnesium ion, due to their small size, show some tendency of complex formation. Next, organometallic compounds. Beryllium and oxygen form a number of compounds with magnesium metal carbon bonds. Example, Grignard reagent. Next, behavior of beryllium different from other alkaline earth metal. Anomalous behavior of beryllium. Ionization potential and electronegativity of beryllium is higher than that of other metals. Beryllium chloride is insoluble in water due to its covalent nature, but insoluble in organic solvent. Other solvent get dissolved in water. Beryllium chloride get hydrolyzed due to its covalent nature. Chloride of calcium, strontium and barium get dissociated. Beryllium oxide and beryllium hydroxide are amphoteric in nature. Therefore, they react with acid as well as bases. Other oxides react only with acid due to their alkaline nature. Beryllium forms single type of oxide. Calcium, strontium and barium form peroxide also. Hydration energy of barium is higher than that of other metals. Beryllium does not give flame test. Calcium, strontium and barium impact characteristics color to the flame. Due to small size, barium form complex compound, other are insoluble in water. Hydrides and halides of beryllium get polymerizes. Beryllium does not react with water even at high temperature, other react even with cold water. Diagonal relationship between beryllium and aluminium. Beryllium show some similarities in properties with aluminium, the second typical element of group 13. of the next higher period. The polarizing power of beryllium and sodium ions is high. Consequently, the compound develop covalent nature. The standard oxidation values of both the elements are very close to each other. The electronegativity value of both the elements are same. Next is some important points of S block elements. KNO3 is used in gunpowder. KO2 is used to obtain oxygen on high mountains. Barium carbonate is a medicine for killing rats. Calcium oxychloride is germicide and a bleaching agent. Barium sulfate is used in X-ray examination of intestines. MgCO3.MgOH2.3H2 is called magnesium alba, which is used for filling up to cavities in the teeth. Calcium cyanide is a fertilizer. Na2BF4O7.10H2O is called borax, which is a mineral of sodium. Complex compound of magnesium and iron are chlorophyll and hemoglobin respectively. Sodium and potassium is kept in kerosene because they are reactive. Lithium is hard and cannot be cut by knife. Sodium, potassium and rubidium are soft solid and cesium is a liquid. Hydration energy of lithium ion is maximum, therefore its conductivity is low. Ionic character is directly proportional to size of cation, directly proportional to boiling and melting points of compound. Superoxide are paramagnetic and colored due to presence of unpaired electron. Lithium carbonate is used in mental disorders. Lithium nitrate and sodium nitrate melt on absorbing moisture of air. KNO3 does not have this characteristic, therefore it is used in gunpowder. Calcium hydride is called hydrolith. It is used in the transportation of hydrogen because it is light and react with ice to release hydrogen. Mixture of water plus sand plus slaked lime is called mortar. A mixture of MgO and MgCl2 and Mg2OCl2 is called sorrel cement. Calcium nitrate is called Norwegian saltpeter. Potassium chloride Potassium chlorate is used in an explosive substance in ammonium and fireworks. So these are some uses of S block elements. Thank you.